we can do is we can actually compare the two. So looking at the two, this and this equal, this and this equal, and basically this is equal to that. Okay, this is basically equal to that, no problem. And what happened with the gy? Gy basically, it's just going to be any constant value. Okay, so because what happened here is there's nothing for the gy, so I can actually let gy to be equal to a constant value. So if I let gy to be a constant value, so what happens here is my function, parent function, x and y is going to be equal to xy squared plus x squared y plus x plus a constant c. Okay, so that is one way of doing. Okay, so that is one way that we can actually approach. So the other way of approaching the problem is, as we mentioned, you start out from your function p, which is basically del f del x. You integrate it, you get your parent function. So we can actually take this parent function, and I take this parent function, I integrate it with respect to y. So then I equate it with q, because what is that? Q is equal to 2xy plus x squared, and this is equal to del f del y. Okay, so I take this, I differentiate it with respect to y, so I get equal to 2xy plus x squared. Okay, so this term disappeared, right? Because I differentiate it with respect to y, and then of course I have g prime y. Okay, so you can actually see that from this expression, this term and this term, they are there, no problem. This term and this term, they are also there, no problem. Except that my g prime y, my g prime y is actually equal to 0, because they have to be the same. Because this is your q, this is your del f del y. This is what you do with your del f del y, you enter out with this. So implying that your g prime y is actually equal to 0. Okay, if g prime y is equal to 0, so what happened here is your gy is going to be equal to a constant. Alright, if gy is going to be equal to a constant, that means this parent function is going to be correct. Okay, this parent function is correct to say that with this function of y, we can actually go back and say that, okay, the parent function is indeed equal to xy squared plus x squared y plus x plus a constant. Alright? Okay? Alright? Any question? So you are very familiar with exact differential. Okay, so exact differential, basically that's what you need to do. You need to determine whether they are exact differential. And then one of the key things, as we mentioned before, if you can prove that a function is actually an exact differential, primarily in your integration, you can also say that the integration will be path dependent or independent. Basically, if you get an exact differential, you can find the parent function, and at the same time, you can actually show that if you were to try to do a path integration, your path will be independent of your integration of that particular exact differential function will be basically what we say path independent. That means if you want to do an integration from a starting point A to a ending point B, all you need to do is you take the function evaluating it at point B minus a function evaluating it at point A, and you should be able to get the integration. Because why? It's actually path independent. Okay, so that is one thing that is actually good when we actually deal with exact differential. Okay, so very quickly, let's take a look of whether we can actually find some example that we can actually use in this the questions. Okay, so what we have here is line integral. Okay, so this is line integral. So we are into line integral now. Okay, so we are asked to evaluate the line integral of, say for example, 2xy. Okay, 2xy dx along the parabola y is equal to 4x squared. From the starting point of A is equal to 1, 4 to B, 3, 33. Okay, alright, so let's take a look of this to see whether it's actually quite straightforward, so or whether it's going to be tedious. Okay, in your exam, you will only, I think most of the time in your exam, you will ask to do double integral. Okay, but you need to know single integral. Your line, your part, your line integral and all that, they are equally important. So we are asked to evaluate this line integral of 2xy dx. Okay, and we are asked to evaluate this line integral of the function along y is equal to 4x squared. So basically, this will basically give us y is equal to 4x squared. So this is your y, this is your x. Okay, so this is y is equal to 4x squared. Starting point A is equal to 1, 4. Well, I mean, I don't really have it very good, the drawing. 1, 4 to the final point of 3, 36. Okay, so if you were to do it, I guess it's actually quite straightforward. Because you're given that y is equal to 4x squared, you can actually do a quick substitution. So you've got 2x, y is equal to 4x squared dx. Okay, and of course for us the integration is going to be from 1 to 3. Okay, 1 to 3, and of course this is going to be equal to integral of 1 to 3 of 8x cubed dx. Okay, so this is going to be equal to 2x to the power of 4, 1 to 3. You should be able to work it out. Quite straightforward. Okay, so what about if you try to do it differently? Can we actually work it out differently? You can, because what happened here is you have y is equal to 4x squared. Okay, we have y is equal to 4x squared. If I have to do dy, what do I get? I get 8x dx. Alright? Right? You have y is equal to 4x squared. So if I try to find the differential of your dy, I ended up with 8x dx. So I can actually go back to my original expression here. Okay, so if I go back to this original expression, so what do I get here is 8x dx is equal to dy. So this is basically, I can actually write it as a line, as a contour integral of 1 over 4 y dy. Alright? Okay, because y is equal to 4x squared. Alright, and then dy is equal to 8x dx. So this is basically equal to 4 times 2x dx. Alright? So 2x dx is something that we can actually work it out. So what is missing is actually a 4. So what I need to do is I multiply by a 4 and I divide by a 4. Okay, and then with that I replace it, and of course this will be equal to integrating it from a point of 4 to 36. Because now you are actually integrating it with respect to y. And of course, if you do it with respect to y, so this is going to be equal to what? This is y squared divided by 8. And you are evaluating it from 36, 4 to 36. Okay? Anyone work out the value? So you get 36 times 36 divided by 8 minus 4 times 4 divided by 8. Okay? Right, so this and this you can actually cancel out. Okay, so this is 2 at the back. So 36, 36, so you can only use 2. You can only use 4, right? 4, this is 2. 4, this is 9. 2, this is 18. So 18 times 9, what do you get? 180 minus 18. 180 minus 18 is 162. 162 minus 2 is equal to what? 160. Okay, so did you anyone work out this? If you work it out, so x to the power of 4, 3 to the power of 4 is how much? 3 to the power of 4 is 8. 3 to the power of 4 is 81. 81 times 2 is 81 times 2 is again 162, right? 81 times 2, 162, and then minus 2 times 1 to the power of 4 minus 2. So you can actually see that you actually get the same answer. Alright? Agreed? Agreed with that? Okay? Alright? Okay, so the next one, we can try.
Do you know how you get the 1/4y?
Okay, maybe we try question number 3. Okay, because question number 3 a little bit of a challenge. Okay, we are asked to evaluate. We'll try question number 3, then we will stop. Okay, so we are asked to evaluate the line integral x squared ds along the curve y is equal to 3x squared from a is equal to 0, 0 to b is equal to 2, 12. And of course, in this question here, you are given a hint. If your integration is of this format, 1 over a, integral of x squared of a squared plus x squared square root dx, you can actually make use of this relationship. Okay? Well, let's try. Okay, so basically what you need to do is you need to express. So we are trying to work out the contour, the line integral of x squared ds. And along the curve of y is equal to 3x squared. Alright, along y is equal to 3x squared from a 0, 0 to b 2, 12. Okay, so what we need to do is we need to express. Okay, so what we need to do is we need to express ds. If you remember, in your in terms of your dx and your dy, so how do you express ds in terms of dx and dy? So ds is going to be equal to dx multiplied by square root of 1 plus dy dx, correct? Squared. Can you remember this? Cannot remember already. This one we covered this about 3 weeks ago, 4 weeks ago. 4 always cannot remember. You are really is what SSD.
What's that?
I would think that your memory better than mine. It should be better.
Oh,
than
the
mine.
computer
Okay, so
that
this is
exists.
basically, if you cannot remember, you go back and you revise your line integral. You look at parametric. We talk about parametric. This is basically one form of it. And then you can actually do, because you see what happened here is when we do our line or contour integral, primarily we integrating it with respect to dx and dy. Sometimes we say that we can actually integrate along the path. That is when you try to integrate it along your ds. And that is one way we can actually write our, our path in related to, in terms of your dx and your dy. Okay, so I guess you have your next lesson coming up. So, okay, now mind. Next week we will continue with this. Okay, we'll continue with this. All right. So I let you go back, revise, and then we will continue next week after your quiz.